calculate the concentration of the precipitating ion that is needed to form each precipitate. This says concentration, the precipitant, I guess I could say that. Precipitant, not precipitate. Okay, so you calculate that by doing the KSP divided by the given concentrations, and then you see which one is the smaller number. That's the first precipitate that forms. Here's the problem. Write the formula to precipitate. If bromide is slowly added, and the reason you don't want to change volumes is obviously you have to change concentrations and everything. It can be done, but I'm just trying to get a few basics here. I gave you the two KSPs. If these concentrations were the same, you'd say right away, this one must, well no you wouldn't, because they have different ratios of bromide to cation. So you can't really look at the KSPs and decide. First problem I did, just to introduce the topic, I picked two things that are both the same formula, silver bromide and silver chloride. And then I could just look at the KSPs and concentrations. But here, you have different formulas, you have different KSPs. This is the smaller one, but you have to go through the calculation. So what you need to do, the precipitant is bromide ion. So you're precipitating these things with bromide ion. To precipitate platinum bromide, and I said one of the things about KSP, you always want to write that down so you remind yourself what the exponents are when you go to set up the equilibrium expression. So you're going to solve for bromide ion because that's what you're adding. And it's going to be KSP over the concentration of platinum ion. And what are you going to do there? Force through. Now a lot of people are having troubles with their calculators. How do you do this problem? Because I noticed that a lot of people have things set up and then I see really strange numbers at the next step. And either you do what I do and push the wrong buttons, or you really don't know which buttons to push. Okay, let's see which buttons. Okay, we're doing this one. As I said, you have to pay attention so you don't mix up the numbers. 3 times 10 to the minus 41. I assume everybody can divide. The platinum is given as 0.025. And by the way, lots of times I see people start off like this, and as they go along, they forget to put some of the parts of the math in. Maybe it's because they don't know how to do it, or maybe they just forgot. Either way, the result is the same. You get a wrong answer. Right. The other thing you always have to remember is to turn your calculator on. So I get 1.20 times 10 minus 39. Now I remember that fraction, 1/4 is 0.25, so I push exponent 0.25, and it gives me the fourth root. If you have asking for some strange root where you don't know the decimal equivalent, what do? you put in 4 reciprocal, and that gives you 1/4, or 7 reciprocal, whatever root you have to calculate. Okay. And most of the new calculators all have the exponent. I always used to talk about my y to the x button on my old calculator because it does the same thing, or the root. And you just put in the number, and then you push the button, and you put in the x, and it would raise it to that power. Or then you could use the fraction in there. But it also had this thing, so you could put either button to take the root or the power. But I think somebody said one of the companies still made that, but almost all the button companies now use what? For all your calculators, caret. So I had to learn how to use the caret. But there it is. I can do it if I can find it. Okay. Caret, and I could say 0.25, but I'm going to say 4. Reciprocal. Enter. And it says 186 times 10 to the minus 10. Now these are problems where you do have to be able to get these numbers, otherwise you can't decide which is smaller. And of course it's molarity. Okay, everybody got that. Then the other one, I want to do the bromide for gold. And it's again KSPs, and the gold concentration was given as 0.42. Now I have to take the cube root. And again, you could use 0.3333, but it's easier to enter reciprocal. And you get 161 times 10 to the minus 12. Now it says, write the formula for the precipitate. You just do this thing and circle that. I'll take a point off because you didn't write the formula for the precipitate. The answer you would write is what? This number is smaller than this number, so you write answer. That's the precipitate. And then it says, the other question I usually ask about this, what's the percent of the first ion remaining in solution? That's the reason I put it like that, is to find out what the first ion is. I don't want to give you the answer to the first question by saying what's the concentration of gold when the other one starts to form precipitates, because then you'll know right away the gold bromide is the first one to precipitate. So I have to put that weird wording in there. So first you have to find the first one to precipitate. Then you want to find out what the gold concentration is as the bromide ion increases to this number. So you're working with KSP for this one again. And what you're doing now is solving for the bromide, the gold concentration, sorry. That's what I just said we we're going to do. But it's going to be, is it going to be bigger than this or smaller than this?
Bigger.
It has to go down. It has to go down because you're precipitating out the gold until the concentration gets up this number when you start precipitating the platinum simultaneously. So it has to be a number smaller than this. So you're going to take KSP over, and you're going to take this number here, and you're going to cube it. concentration in this particular equilibrium.
So am I going to the whole problem, not just the bottom?
What?
To the third? Isn't it the whole problem, not just the bottom part?
No, what we're doing, we're still doing this. Right? So first thing you have to do is make sure you use the right number for the KSP, and you're solving it for the gold concentration. Because you want to, the gold is the first one that forms the precipitate. That's what we decided in this part of the problem. Okay? So what we want to do is work with gold. Since that's the first precipitate form, it starts forming at a low bromide concentration. Now, as you're precipitating, as you're adding bromide, the reaction's going this way, this number is going down, and this number is going up. That's what it says in here. You're adding more bromide, this goes up, this has to go down because it's equal to a constant. Eventually, it gets up to this number, the higher concentration, and now you start precipitating platinum 4 bromide. Okay? So that's the number you want to plug in here, and you want to see what the gold is when you get up to this higher number for the bromide concentration. So first I'm going to do...
Sorry.
Question? Yes?
What was it cube? What was it grade?
Because again, remember, gold times bromide cubed, because here's the dissociation reaction. That's why I said it's important for KSPs that you always write down the dissociation reaction so you remind yourselves what you're going to do in the equilibrium expression. If I gave you something like, you know the equilibrium expression is what? 5 plus. Squared, what am I doing here? In other words, you do that by writing the dissociation reaction. And somebody said, shouldn't I take the cube root? But I'm solving for this. If I solve for this, I'm dividing KSP by what?
The
this
bromide
number
concentration.
here is the cube, not the cube root. Okay. Question? Everybody's looking puzzled. What's the question? There must be a question. No? You don't want to ask me? Ask her. Nothing wrong because she wants to pass and let you fail. I don't know. Okay, so coming back to this thing, this is the higher number. That's what went in here. I'm cubing it and I'm solving for this number. And if I did it wrong, I've mixed up my numbers, what's going to happen when I get this number? It's going to be bigger than this number. Then I know I picked something wrong. Yes?
He's solving for
Gold. Right. Because it said the formula, wait a minute, right here. The first ion, what is the percent of the first ion remaining in solution? Gold was the first ion, that's what we had, that's why we had to do this first problem here, to decide which was the first one to precipitate. Okay. Yes?
So we solve for the concentration of bromide first, and we decide which one
No, we're
precipitate.
solving, yeah.
Well, I'm just kind of going step by step to see if I'm staying in line with
Yeah,
you.
in other words, here we want to see what the bromide is to make this precipitate. Remember we did the other problem in the last quiz where I gave you these numbers and you calculated, I called it P, the book calls it a Q, or